Hi everyone. So let's go back to what we were doing. So what we were doing is that the structure of ZP and Zn. So we have the following result theorem. So ZP will remind us of R because with R you can actually invert operations. You can invert the real numbers. Any real number has an inverse, and with ZP that turns out to be the same thing. Any prime would have the inverse, and it really can be traced to Bezout's identity. Okay, so we have the following result. So theorem 2.8. If p is bigger than 1 is an integer, then the following are the following conditions are equivalent. First thing is first, p is prime. The second condition, for any a not equal to 0 in ZP, the equation AX is equal to 1 has a solution. In ZP. And the third thing is that whenever BC is equal to 0 in ZP, then B is equal to 0 or C is equal to 0. So let's prove 1 implies 2. So first of all, assume that A is not equal to 0 in ZP. So that means that P doesn't divide A. So therefore, the GCD between A and P is equal to 1. So hence, by Bezout's identity, you have the following. You have A times V, or A times U, plus P times V is equal to 1. So that means that AU minus 1 is equal to P times V prime, where V prime is equal to minus V, which is in the Z. So that means that AX is equal to 1 has a solution, being solution X is equal to U. Alright, so let's see the next problem. All right. So 2 implies 3. So assume that A times B is equal to 0, and we can assume without the loss of generality that A is not equal to 0, because if A is equal to 0, then we're done. Then what you can do, you can multiply by the inverse in both sides, since we have a solution by part 2. So that means that A inverse times A times B is equal to A inverse times 0. So that means that B is equal to 0 and we're done. So we either have A is equal to 0 or B is equal to 0. All right. You can also do it by many things. All right. Okay. So let's go to 3 implies 1. So suppose we want to show the following, that P is prime. So suppose that P divides BC. So then by the third condition, we either have P divides B. We either have. So that means that BC is congruent to 0 mod P, which means that B, by condition 3, B is equal to 0 mod P, or A or C is equal to 0 mod P. Hence, P divides B or P divides C, and we are done. So yeah, I hope you guys enjoyed this video, and I'll see you in the next one. Bye now.